has the highest entropy. Now let's get back to tomorrow. What we discussed. We
In
discuss
it,
about we discussed about events and we discuss about the probability axiom where we believe that randomness. What is randomness? So randomness is a thing which says that there is high probability of an event happening, but we don't know which event will happen. That we yesterday says that either A or either B or either will get when we toss a coin, there is probability that we get a head or there is no third, but we don't know head or we get a tail. That possibility. Which I take an example of patient A. So patient right. So probably 5% probability. It's clear to them that yes, 95% probability of getting the disease. It means that
ನೆಟ್ ಬಂದ್
yes,
ಮಾಡ್ಬಿಟ್ಟು ನೋಡ್ರ
70% probability of not getting the disease. So it's simple. He also knows that yes, 70% time I have a probability that I will not get the disease. There is only 30% probability that I might get a disease. Now let's go to patient C. When we talk about patient C, it's an important thing that it is the perfect example of randomness. That he has 50% probability of getting a disease and 50% probability of not getting a disease. And that is what is known as randomness. That is what is known as information entropy, where patient C does not know what's going to happen. It can happen with full probability, and that is what the theory of randomness explains to us, that
ಚಿನ್ನ ನಿನ್ನ ಮೊಬೈಲ್
either of the event can happen, getting a disease, not getting a disease. Both of these event can happen, but we don't. So this is what is known as this is what is known as information
ನಿನ್ನ
entropy.
ಮೊಬೈಲ್ ಕೊಡಮ್ಮ
So
ಇಲ್ಲೇ
now,
ಇರ್ತೀನಿ.
intuitively speaking, what good enough for waiting room talk, but from a probability and certainty perspective, it's not good. So entropy allows us to make precise statements and perform computations with regard to one of like how things will turn out. So when you develop a machine learning model, especially a machine learning model that is used to describe categories, information entropy plays a very crucial role. Remember, we are going to talk this in some time, but the objective of a machine learning model or learning of the machine learning model is to minimize entropy in the system. Okay, is to minimize entropy. It means minimize uncertainty in the system and increases certainty, right? That is the overall objective of all the machine learning algorithms. Few examples here, such as the random forest, then decision trees, gradient boosting, extreme gradient boosting, deep learning model. All of these models are purely based on this simple concept, wherein they start learning from data. And when we say they are learning from data, it means iteration by iteration. See, one iteration complete, a mathematical formula is now available. The second iteration starts. In the second iterations, when the second iteration starts, the machine learning model tries to minimize uncertainty and reaches towards certainty and say that, okay, now I have learned if all X, Y, Z conditions are there, then there is highest probability of an event happening or the event not happening. And this is a concept of information entropy. Let me take a very quick pause here for 10 seconds. I invite questions. If you have any questions, any doubt, or if you want me to repeat this again, I would be very happy to do that. But this is very important. So please, if this is not clear, then we can discuss, we can spend some more time on this concept. Okay, so now I understand that this is clear to most of us. So if you have any queries, because we are moving on from this topic from probability to our next topic for the day. So if you have any queries, then please raise. Otherwise, we will proceed. So Arunjit, we can discuss the p-value now, or we can proceed with the other topics of machine learning and AI, as you say. Arunjit, are you there?
Sorry, can you hear me? Sorry, I was on mute. Can you hear me now?
Yeah,
And I'm
yes,
saying
yes.
that you want to touch upon the Bayesian part, or you want to do that later, probably.
No, we will do that later because from the yeah.
That's okay. Okay. We can start with the p-value, but that is also important.
Okay. So let's utilize the morning thing where we have focus from every one of you. Let's touch upon some of the other important concepts that are essential for learning. Essential for learning how a machine learning model works and how do we validate the machine learning models. So we are touching upon some of these concepts. We talked about information theory, and the next important concept is known as p-value or probability value. So once again, I am sure all of you would understand that yesterday when we were talking about probability, I repeatedly mentioned that probability is extremely important when you talk about machine learning and AI. And we talked about information entropy now, wherein the concept of wherein we had the important concept of randomness and that the machine learning model basically when they try to learn from the data, they try to minimize the overall uncertainty or overall entropy in the system. Now, this is another concept which is known as p-value or the probability value. Now, where this probability value comes and why is it important and what is the role of this probability value that we are going to discuss now. So, suppose a pizza place claims that delivery time are 30 minutes or less on average. But you think it's more than that. Okay. So now we have two thoughts in mind. So one is a pizza delivery restaurant that talks about that they can deliver pizza to you in 30 minutes or less than 30 minutes. This is their claim. But as a customer, you believe that they are not claiming it right, and you believe that on average, their delivery times are either 30 minutes or they are more than 30 minutes, right? So now we have two things in our mind. One thing, it says that they deliver less than 30 minutes, and second is what is known as they deliver for more than 30 minutes. So now that yes, I strongly believe that when I drive from Delhi to Pune with a truck that is carrying almost 20 tons of food, that is, I will reach on time, and then you want to challenge that. You believe that okay, if I have to believe that you will reach on time, but I challenge saying that you will not reach on time. So similarly, every cross-statistics or machine learning has two hypotheses. One hypothesis is the main hypothesis wherein we say that okay, we want this. For example, prediction of a car failure. Now you will say that based on the data, I can predict a car failure. So that becomes your hypothesis, and the second hypothesis becomes that based on the data, you cannot predict a car failure. Okay. So this p-value actually helps you to validate your hypothesis, and every analysis that you do using machine learning and AI, all of them are basically hypothesis tests. So to conduct a hypothesis test, we randomly sample some delivery times to test the claim. Are you with me all? Are you getting this all? That what are we doing? We are ordering certain numbers of pizzas from that particular restaurant, and we are also ensuring at the same time that we are getting some data from different vendors from different people who ordered that pizza. So ultimately, the objective is to randomly collect the sample. Okay. Here also the most important point is random. Please remember, we are randomly collecting samples. Let's proceed and see. So now hypothesis testing is used to test the validity of a claim that is made about a population using a sample data. This is important because population is large. Now, the pizza restaurant probably would be doing 100 deliveries in a day and maybe more than 3,000 deliveries in a month. But you cannot, and then as you go on adding them to years and years together, you get more and more number of samples. But as a statistician, we cannot collect all the data of population, all the data or what we call as population and do the analysis on it. What we do is we collect certain number of samples. So you collect 10 samples today, you collect 10 samples tomorrow, you collect 10 samples for a week's time or for 15 days time, randomly throughout the day. For example, you collected before 12 in the morning, you collected between 12 and 4 in the afternoon, and then you collect after 4 to 8 in the evening. So you collect few samples and then you keep on adding those samples every day. So what you are trying to do is that you're trying to ensure that you collect some samples from the population, and the analysis that you do based on the sample data is applicable to the entire population. I'm sure all of you are getting this concept that we are preparing or we are doing our analysis on sample data, but we want to ensure that whatever analysis we do on the sample data is applicable to is also applicable to the entire population. Now let's take another example here. Suppose you have 10 GB of data and you want to develop a machine learning model. Now to develop a machine learning model, first of all we have to divide the data. Okay, so you had a population of 10 GB. You divided the data into 8 GB and 2 GB. So 8 GB is the data on which you are going to train your so your models are going to learn on that data. At the same time, you have a 2 GB model, or you have a 2 GB data on which you are going to test your model, right? So you have 10 GB data, you are dividing that into 8 GB and training and 2 GB for testing. So both of them became samples. So whatever analysis you find out, whatever model you develop, you want to ensure that yes, either I train the model or I test the model. Whatever model I develop, they both are applicable to each other, and that is what is known as hypothesis testing of and finding on sample data is also applicable to the population data. Now let's go deeper into it, understanding what is known as null hypothesis and what's known as alternative hypothesis. So null hypothesis, in the case that we were discussing about, the pizza delivery, the mean delivery time is 30 minutes or less, right? So that becomes the mean delivery time because ultimately somebody is claiming that our delivery time is less than 30 minutes. So they are claiming it, and now we are questioning that claim. So that becomes the null hypothesis, and the alternate hypothesis is exactly opposite to it, where we say that the mean delivery time is greater than 30 minutes. Are you all getting the point? Null hypothesis is mean delivery time is less than 30 minutes, is 30 minutes or less. An alternate hypothesis is that the mean delivery time is greater than 30 minutes. I'm taking a quick 10 seconds pause. Can you all, is this all clear to you? What is null hypothesis and what is alternate hypothesis? Please help me with your comments on chat box. If you want to know a little more, we can talk about it a little more. Or is this clear to you? Null hypothesis? Okay. So null hypothesis is what we are, our statement, is our objective, is our target, right? So for example, I can come and say that I do not have a disease. So I do not have a disease becomes my null hypothesis, and what becomes my alternate hypothesis is that I have a disease. Are you getting it? That based on the data in the earlier entropy case, where the patient A said that there is 95% probability of the patient having a disease, then patient has a disease become my null hypothesis, and alternate hypothesis becomes that patient do not have a disease. For patient number A, where there was 95% probability of getting disease, right? So that becomes null hypothesis, and we have an alternate hypothesis. Is this clear to you all now? Okay, so now when we are clear with the concept of null hypothesis and alternate hypothesis, let's bring a little twist here, okay? And everybody please listen to this very carefully. When we are trying to prove that null hypothesis is true, what we try to prove first is that the alternate hypothesis is, when we are trying to prove that the null hypothesis is false, because it is a true statement. We have already accepted that. We have accepted that the mean delivery time of a pizza delivery restaurant is less than 30 minutes. We have already accepted that. Now, what we are trying to prove is that it is wrong. So, to prove that null hypothesis is wrong, that is the delivery time of a pizza less than 30 minutes. What we are trying to prove is that it is more than 30 minutes. So, we don't focus on proving that that the null hypothesis is wrong, but we focus on proving that the alternate hypothesis, that is the mean delivery time, is greater than 30 minutes. So we try to prove this, okay? So the goal here is to determine which claim, the null or the alternate, is better supported by the evidence found from our sample data. Now, what is the sample data? Can I quickly ask you what sample data in this case is when we actually collected some of the delivery time I give you an example that we are collecting delivery time of 15 days, some delivery time between when the time is less than 12 o'clock, between 12 to 4 p.m. and more than 4 p.m. So these are known as sample data that we are collecting. Okay. From here, let's move on to the next section that talks about, now you collected the sample, okay, viewers, and we will prepare a data set for it. Okay, in the data set, what you will have first column is the serial number, the second column as the date, third column as your time, fourth column as your area, fifth column as your on time or delay, or maybe fifth column as the time in minutes. Okay, so this way you have 5 different columns, and the time part when the deliveries was say in some cases the delivery happened at 29 minutes, some cases the delivery happened at 32 minutes, at some cases the delivery happened at 26 minutes, some cases the delivery happened at 40 minutes, happened at 37 minutes. So similarly, when you started collecting samples on different days and different time of the week, what you do is we prepare a histogram. I'm sure all of you would remember that yesterday we had prepared an histogram. So similarly for the data, what we do is we prepare a histogram, right? Now when we prepare histogram, some of the findings that we get from the histogram is basically that what is the mean, what is the median of the histogram. Now, when the distribution is normal or when the distribution is symmetry, the mean and median are same. Okay, so mean and median are same. Now we have all the data that is available with us. We plot a histogram. Our next step now is to calculate what is the mean and what is the standard deviation. Now, why do we calculate the standard deviation? Because we have a mean, and the mean says, for example, that the mean delivery time of the pizza from the restaurant is 30 minutes. So we have a mean value which is 30 minutes. But what if the standard deviation is 10? It means that if the standard deviation says that no, the standard deviation is 10, then it means that if the standard deviation of a pizza delivery time is 10, then either you will get the pizza between 20 minutes to 40 minutes on both the sides. Standard deviations are 10 is equal to 40. So we receive the pizza between 20 minutes to 40 minutes. Okay. Now, based on this distribution, based on the mean and standard deviation, we calculate something which is known as Z-score. Now, what is the purpose of the Z-score? It is the same purpose that Z-score tell you that the overall data lies compared to the average population. It means that the average population is somewhere between the middle of this line. If you can right now look on your screens, then the average population, even if you remember yesterday we talked about box plot, we gave an example of outliers. There also you can see that there was a cluster where most of the population or the average population lies. So basically now you identify the Z-score, and the Z-score tell you that how compared how is the overall data as compared to the average population. It means the data is densely populated, or if the data is if there is too much spread in the data. Now, the higher or lower the Z-score, the more unlikely the result is to happen by chance, and the more likely is the result is meaningful. What it means that when you are collecting sample data, okay, when you are collecting samples, when you are ordering pizzas and noting down what was the average time that the restaurant took to deliver the pizza. So once again, we get back to the same part of theory of randomness, where when you believe that okay, sometimes when the pizza delivery took more time than 30 minutes, that was not by chance. Okay, there sometimes something happens in life. So when you observe that okay, the pizza delivery time was more than 30 minutes, that was not by chance. When I say by chance, it means because sometimes it happens. Sometimes you drive, sometimes the pizza delivery was driving a scooter, the tire punctured. That doesn't happen every time. It only happens sometimes. When the pizza delivery was guy was driving, then the road were closed or the fuel get empty, because such events that do not happen every time, those events are said as that happen by chance. So suppose that you observe that the pizza delivery guy who is delivering this pizza to you is consuming more than 30 minutes of time. You want to ensure, please listen to me carefully. When you observe that it is taking more than 30 minutes of time, you want to ensure that did not happen by chance, but that is a usual way, right? That is a usual way. So that is how we are trying to ensure that if something happened by chance, okay, let's assume that he was delivering the vehicle, the tire punctured, and he was not able to reach to you on time. Then, if that is not a usual pattern, then that would be called as an outlier. Okay, so yesterday we saw some of the statistical practices and some of the visualization practices that help you identify outlier. Okay, so what you are ensuring is that whatever sample you are collecting, that sample has minimum amount of chance, has minimum amount of chance or minimum amount of some error of happening in the data, right? Is this all clear to you? Let me take a quick 10-second pause. I want all of you to confirm me if this part is clear to you, that the objective, what we have learned till now, is to ensure that whatever sample you are collecting from the pizza delivery guy, all those samples have less amount of error and less amount of something happening in the data by chance. Okay? It's okay. So can you? I'm taking a 10-second pause. Can you all please confirm that you got the point? Okay, so we have one response. Right. So before we proceed ahead, let me repeat. What are we saying is, we are statistically calculating or we are statistically ensuring that whatever data we are collecting for doing the hypothesis test or developing our machine learning models, those data are not collected by chance or they do not have a factor by chance. They are all usual values and the amount of error is less in the data. Okay, so basically we're trying to ensure that the error in the data is less, right? But and to do that, we are calculating what is known as a Z-score. So we are saying that the higher or lower the Z-score, the more unlikely the result is to happen by chance. But then yesterday we talked that there has to be a thumb rule or there has to be a threshold beyond which we call it, okay, this is an outlier or this is not an outlier. Similarly, there has to be a threshold for the Z-score where we can say that, okay, if the Z-score is more than this or if the Z-score is less than this, then we will call it, that yes, the results or the sample data has less error. And to calculate that Z-score, what we have is a probability value. Now let's go to our main topic for the day, that is what we call as the p-value. Now I'm sure all of you remember before we came to p-value, what we started, what first of all we defined what is null hypothesis and what is alternate hypothesis. Null hypothesis is something that we are trying to prove or which is a stated accepted statement like sun rises in the east. Now sun rises in the east becomes your null hypothesis and your alternate hypothesis becomes sun do not rise in the east. Okay, so you're accepting something and in order to prove that this is right, you prove the other part. You prove that sun do not rise in the east. So that is known as an alternate hypothesis. Now to do that, what do? Every day morning you get up at 5 a.m. or 6 a.m. and then start noting down at what time the sun rise, in which direction the sun rise. Okay, but you cannot do it for the entire lifetime. You can only do it for say 1 month, 2 months, 3 months, or few years. And then you can also request some of your friends to do the same thing. But even if your thousands of friends get up in the morning and collect this data for thousands of days, those will still become a sample that does not become a population, right? So now you want to ensure that whatever hypothesis or whatever analysis you do on the sample is applicable to the entire population. You try to plot the data, you try to look at the Z-score, and the Z-score help you understand that yes, there is less error. Okay, so it's not that some of your friend got up late and he did not see the rising sun, and he simply saw sun on the sky and then noted down, okay, it goes in the east. So that would be error. Or some of your friends did not wake up in the morning, wake up at noon at 12 o'clock when the sun was on the head, and in order just to say that, okay, I did not get up in the morning, he writes down that yes, I saw it, that the sun rise on Sunday from east. So these are some of the errors which are in the data. So with Z-score, you're trying to ensure that there are no errors in the data or no, there was nothing in the data that was collected by chance. Okay. Now, there is a threshold beyond which we will say that, okay, we will accept that there is no error in the data, and below which we will accept that, yes, there is error in the data. So now what do we say that the p-value is used in hypothesis testing to help you support or reject the null hypothesis. The p-value is the evidence against the null hypothesis. Please remember that the p-value is evidence against the null hypothesis. And why is it evidence against the null hypothesis? Because we are never trying to work on null hypothesis. We are always trying to work on proving that the alternate hypothesis is the right. So we are trying to prove that sun do not rise in the east. We are trying to prove that the pizza delivery time is more than 30 minutes. We are never trying to prove that it is less than 30 minutes. We are always trying to prove the other hypothesis, the alternate hypothesis, and that is why the p-value is the evidence against a null hypothesis, right? The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. Let me rephrase it again. The smaller the p-value, the lesser the p-value, the strong evidence that you should reject the null hypothesis. And when do we reject the null hypothesis? When we are able to prove that the alternate hypothesis is right. It means the smaller the p-value, the stronger is the evidence that the alternate hypothesis is right. Okay, so the smaller the p-value, what is our alternate hypothesis? That sun do not rise in the east, and the second pizza delivery takes more than 30 minutes. That is our alternate hypothesis, right? So we are now focusing on smaller values. Let's proceed ahead from here. Let's go to p-value. P-value is known as probability value. From here, the next slide will further clarify it. Okay, for example, a p-value of 0.00254 is 2.54%. Okay, it means that we convert this into percentage, and percentage is 2.54%. This means that there is only a 2.5% chance that your results could be random, or in a simple sentence, you understand this as that there is only 2.5% probability that there is error in your data, Okay, so the lower the p-value, if the p-value is 0.02, so it helps you understand that there is only 2.5% probability that the data you collected, based on the data that you collected, you started analyzing, you started proving that the alternate hypothesis is right, and in that data, there is only 2.5% of error. Okay, remember that we are trying to prove that the alternate hypothesis is right. Okay, when we prove that the alternate hypothesis is right, we automatically reject the null hypothesis. So we are trying to prove that alternate hypothesis is right. Now, interesting point. When you collected the sample data of the pizza delivery, okay, your mean delivery time is longer by 10 minutes. Okay, what does it mean? That when you started collecting data for maybe 1 month of time, you collect 10 samples a day. So in all, what you have is more than 300 samples. Now, of this 300 sample, when you calculate the mean of those 300 sample, you realize that the mean of those 300 sample is 40. Okay, it takes 40 minutes. Now, based on the mean time, it is not right to reject it. Based on the mean time, you cannot come and say that, okay, I sampled 300 data points, and based on the 300 data points, my mean delivery time of the pizza delivery was 40 minutes. It means that whatever the pizza restaurant is claiming is wrong, because that's not right. It is wrong. Why? Because whatever you did is on sample, and you want to ensure that whatever you do on sample is also applicable to the larger population. So based on your mean that you collected based on 300 samples, you cannot reject, you cannot accept value helps you. So on the other hand, a larger p-value, right? If the p-value is 0.9, means your results have a 90% probability of being completely random and not due to anything in your experiment. Okay, so it means by chance there is error. If your p-value is zero point 0.9, there is 90% probability that there is error in your data. And when the p-value is lower, such as 2.5, it means that there is only 2.5% probability that there is error in the error in your data. Okay, so let's go ahead and now focus that you observe that your mean time is 40 minutes. So for that, we have a significant value. Now, what is this significant value? So significant levels are controlled by the researchers and are related to confidence level. It is related to confidence interval. It is related to confidence level. What does this confidence level mean? It means that whatever finding you do based on your experiment, you repeat it for in 2021 for the month of April. Okay. Now, is it applicable? If I ask you the question that you did it for April month for 2021, but is it applicable to the month of June of 2021? Will it be applicable for the month of January for 2022? Will it be applicable for the month of say April 2022? So that is where confidence interval or confidence level come to picture. It helps you if you define that, okay, I want to do an experiment with 98% confidence level. Experiment you do in the month of April 2021 is applicable to all the other future months and all the other historical months. It is applicable everywhere with 98% confidence, only 2% chance that there would be an error. So that is known as a confidence interval. Now, when you start an experiment, you define that my confidence is 95, and so it means that there is 5% probability of error, and that is known as a significant value. So when your p-value, okay, when your p-value is less than your confidence value or your